Introduction to Queuing Theory. Queuing theory is the mathematical study of waiting lines, which are the most frequently encountered problems in everyday life. A queue forms when there is more demand for service than there is facility for service available. It is extremely useful in predicting and evaluating system performance. How long must a customer wait, and how many people will form in the line? Queuing theory attempts to answer these questions through detailed mathematical analysis. The term customers is used in a general sense and does not imply necessarily a human customer. Applications of queuing theory: traffic flow, aircraft, people, telecommunications. Scheduling, patients in hospitals, jobs on machines, programs on a computer. Facility design, post offices, amusement parks, fast food restaurants. Ticket sales counter, etc. A machine's waiting to be repaired, patients waiting in a doctor's room, cars waiting at a traffic signal, and passengers waiting to buy tickets in counters form queues. Common to all of these cases are the arrivals of objects requiring service, and the attendant delays when the service mechanism is busy. Definition of queuing system. A queuing system can be described as customers arriving for service, waiting for service if it is not immediate, and if having waited for service, leaving the system after being served. Characteristics of queuing processes. Arrival pattern of customers. Service pattern of servers, number of servers and service channels. System capacity. Queue discipline. Arrival pattern of customers. In usual queuing situations, the process of arrivals is stochastic, and it is that necessary to know the probability distribution describing the times between successive customer arrivals, inter-arrival times. It is also necessary to know whether customers can arrive simultaneously, batch or bulk arrivals, and if so, the probability distribution describing the size of the batch. The arrival rate follows a Poisson distribution, and hence, the inter-arrival time follows an exponential distribution. Arrival rate is usually denoted by lambda. It is also necessary to know the reaction of a customer upon entering the system. A customer may decide to wait no matter how long the queue becomes, or, on the other hand, if the queue is too long, the customer may decide not to enter the system. If a customer decides not to enter the queue upon arrival, the customer is said to have balked. A customer may enter the queue, but after a time lose patience and decide to leave. In this case, the customer is said to have reneged. In the event that there are two or more parallel waiting lines, customers may switch from one to another, that is, jockey for position. Service pattern of servers. The mode of service is represented by means of the probability distribution of the number of customers serviced per unit of time or the inter-service time. We shall deal with only those queuing systems in which the number of customers serviced per unit of time has a Poisson distribution with mean mu, or the inter-service time has exponential distribution with mean 1 by mu. Number of servers and service channels. There may be one or more servers to provide a service. A queuing system may have only a single channel of service or multi-channel queuing system. In the second figure represent, the servers are fed by a single queue, and third figure, each server is fed by its own queue. System capacity. Number of customers allowed in the system can be either infinite or finite. In some situations, only a limited number of customers are allowed in the system. I.e., some queuing processes there is a physical limitation to the amount of waiting room, so that when the line reaches a certain length, no further customers are allowed to enter until space becomes available as the result of a service completion. These are referred to as finite queuing situations. But in general, number of customers in the system is infinity. Queue discipline. Queue discipline refers to the manner in which customers are selected for service when a queue has formed. A common discipline in everyday life is first come first served, FCFS, or first in first out, FIFO. Last come, first served, LCFS, or last in first out, LIFO. Random selection for service, RSS. In queuing system, we shall assume that service is provided on the FCFS basis. Kendall's notations. Generally, a queuing process is specified in symbolic form as A/B/D, D/E, where A arrival distribution, B service distribution, C number of series, D capacity of the system, EQ discipline.